Hello, Namaste. Welcome to this channel Chemistry Made Easy by Dr. Ashok Mori. Today we will see next part of this ionic bonding, that is general characteristics of ionic solids. So we have seen that last time ionic bonds are formed between the oppositely charged species, that is a cation and an anion. So because of this electrostatic force of attraction, the bond is more stronger, and because of this it shows some specific properties. In addition to this, the bond has also polar nature. So in short, we will see the crystal structure of these ionic solid is also specific. So we have to see the first property. Then second is polar nature. The ionic bonds are polar, so we will discuss it in detail. Then it is also it shows ionic solids, whether it shows or not electrical conductivity, so that we will discuss here. And it's a hardness and brittleness. Now, if we take the first property, that is characteristic of this ionic solid, that is it's the crystal structure. So what is crystal structure? When the number of atoms of or number of ions, that is cations, and number of anions are packed inside the crystal lattice, then each of this anion or cation is surrounded by specific number of oppositely charged ions. So if we take a cation, it is surrounded by a specific number of oppositely charged ions, that is anion. If we consider a anion, it is surrounded by a specific number of cations. So this gives us the crystal structure or lattice pattern of the arrangement of cations and anions in the solid. So on this basis of nature of packing arrangement of the oppositely charged ions, the crystal structures are different, so that we will discuss later on. But in here we will see that the crystal structures are like cubic crystal structure, cubic close packed or simple cubic, end centered cubic, face centered cubic, etc. Similarly, there are other structures like the HCP, hexagonal close packed, etc. So there are a variety of such crystal structures, and these crystal structures are obtained by using X-ray diffraction studies. So these are obtained by X-ray diffraction studies. So these studies shows that the given cation or even anion is surrounded by a specific number of oppositely charged ions, and from this we can find out the crystal structure of the solid. So in this way, the crystal structures are obtained by using these oppositely charged number of, that is coordination number of the ions present in the lattice. Then we can see the simple structure, that is cube, like this. So you can show the shape of the cube like this. So this is the shape of the cube, and depending upon the arrangements, we can show whether it is face centered, close packed cubic structure or simple cubic structure. So this is a simple cubic structure. So here we can find that there is one atom available or present at the center. Then there are other atoms occupying the corner positions like this. So these are the corner positions occupied by oppositely charged ions. We have shown these ions in relatively smaller size in order to understand their positions. But actually there is no such large difference or large distance between the ions. These are in close contact with each other. So we have shown this type of arrangement in order to only understand their positions and the shape of the crystal lattice or unit cell. This is called a unit cell, and its structure is cubic. Then when we have still further type of arrangement, that is this, there are some ions occupying the centers of the faces, then it will look like this. So each face has one ion occupying the center of the face. So this is called face centered or cubic structure. Face centered. Cubic structure. In still some other structures, there are some corner positions. Corner positions occupied by the ions. So we can show like this. These edge centers, these are called edge centers. So you can have these edge centers marked in this way. Like this. So there are, this is also called face centered cubic structure. So such type of structure is obtained in sodium chloride, NaCl, where you will find that the Cl minus ions. So for example, if we label this, say these are say Cl minus ions. So this is Na plus, Na plus. So there is this again Cl minus. So face centers are occupied by here Cl minus. Corner positions are occupied by Cl minus. Edge centers are occupied by Na plus, and at the center there is Na plus. So in this way we can have the face centered cubic structure. This is shown in case of say sodium chloride. So there are variety of such structures shown by ionic solids. Then we will see the next point, that is polar nature. So we can have say that this is NaCl. Here Na is plus and Cl is minus. So if we consider say sodium chloride solid, it has cations and anions, and they are bound together by means of electrostatic force of attraction. So the molecule is having a polar nature. So it has positive pole and this has negative pole, and that is why it is called polar nature of the ionic solids. Then if we see the next point, that is electrical conductivity. So if we take ionic solid, it has structure like say this NaCl, but these ions are strongly packed and these are not easily mobile. The ions cannot move easily anywhere inside the lattice. So because of such strongly packed structure, the ionic solids are are not showing electrical conductivity, means they are bad conductors of electricity. But when they are obtained in molten state, after heating, the ions become mobile, and such mobile that is molten state of ionic solids can exhibit electrical conductivity easily. So ionic solids in their solid state, ionic compounds in their solid state are bad conductors of electricity, but when we obtain these solids in the molten state, they are good conductors. Or when these solids are dissolved in polar solvent like water, they can also exhibit electrical conductivity. Then we will see this next characteristic, that is hardness and brittleness. So this type of hardness arises due to the strong binding between the cations and anions. So the electrostatic force of attraction is very strong. It binds the cations and anions together very strongly. That is why generally the ionic solids are hard. And we can observe that these solids show varying the distance between the ions. It can show the variation in distance. So if we consider CaO, SRO, BaO, so in this order we can find that the interionic distance decreases and the hardness also decreases in the same order. So hardness and this interionic distance, they decreases in this order. So in this way we can explain the behavior of the hardness of the ionic solids. Then if we see the two solids, for example the LiCl, and if we consider another solid, that is SRO, strontium oxide, that is LiCl and strontium oxide, then we find that this Li plus has positive 1 plus charge and this has Cl minus charge. Then Sr ion has 2 plus charge, oxide ion has 2 minus charge. So because of this strontium oxide is harder than this LiCl. So LiCl is relatively softer than SRO, that is strontium oxide. So this is explained on the basis of number of charges. Then we can show another behavior, that is brittleness. So it has hardness and brittleness. So brittleness means if we consider a chalk stick, if we take a chalk which is used for writing on the blackboard, so we can break it easily. So it is called brittle. Why it breaks? Because the ions which are lying on the surface of this broken edge are separated from each other, which are very strongly packed before breaking the solid. So we can explain this in this way. If we say these are the plus minus ion, so these in lattice, so cations, anions like this. So there is alternative arrangement like this, means every cation is surrounded by negative charge. So negative ion is in contact with cation, positive ion is in contact with negative ion, that is anion. So in this way the arrangement is repeated here. So you can find here structure like this. But so this is before applying any pressure or force. So on applying force, it breaks. Say if we apply this force at this center force, force is applied here. Then what happens? The two ions are very moving, or we can slightly shift this here, application of force. See, if we apply the force here, force is applied here. So what will happen? This much portion is shifted in this direction, but this portion of the lattice remains stationary. Then what happens? In the next diagram we can show this like this. So we can have a structure like this. So after forcing this portion in this direction, the negative ions come closer, positive ions come closer in this way. So we get this type of structure. But here the same ions or like ions are coming closer. So that is why there is rupture or there is breaking of the solid. So the solid breaks into two pieces. So that is called brittleness, because the like ions are coming closer and these are showing repulsion. They are repelled from each other. So this is called brittleness. Brittleness. So with this we will stop here our discussion, and we will see the next part or remaining part of this ionic characters in the next lecture. Thank you very much. Please keep watching this video and sharing this video with your friends. Please press bell icon button and like button. Thank you very much. See you next time.